Welcome back, class. Mr. Rasmussen here. We are going to begin our Unit 3, so our third unit. And in this unit, we're just going to talk about the chemical basis of life. And essentially, we're going to just talk about basics of chemistry. So this is going to be an introduction into chemistry and the biology related thereof. So with that being said, let's begin. So our first part, so today what we're going to talk about is this idea of matter. And I know you've been taught about, you've learned about matter in every single class, every single science class, and I'm sure you know what matter is and can distinguish from matter from non-matter, but let's do this as a sort of review. So matter, what matter is, and I'm sure all of you can tell me that matter is anything that has mass and takes up space. So anything that has mass and takes up space. And how we do to measure this, or what we do to measure this, mass, we measure in grams. So over here, we put it on a mass balance, and we come up with its mass in grams, and that's a measure of how much stuff is in this apple. And then the other one is space, is volume. So we measure space through volume, or in milliliters. And a lot of times we do that by displacement. So if we have a cup of water here, we can place, it's not a very good cup of water, I'll put it down over here. If we have a cup of water here, we can put an object in the cup of water. So if we were measuring the volume of this object, we put it in the cup, and however much that water rises is how much space the object took up, and we call that displacement. So that's a way that we can measure volume. Now, if we're talking about matter, there's a bunch of different ways to classify matter, and one way we can classify them is an element. And an element is a pure substance that cannot be broken down into other substances. And what I mean by this is water is a great example. So if we take H2O, so if I take water, and I have a beaker of water again here, I have lots of beakers of water today. Here's my beaker with water in it. And I run electricity through this. I run an electric current. Here's a little lightning bolt. I can separate that water into hydrogen gas and oxygen gas. So we can separate water into its component parts. Now, there is nothing I can do to separate hydrogen gas. I can't do it. I can't separate hydrogen gas. I can't break it down into other substances because it's made up of just hydrogen. So this hydrogen here is an element. Cannot be broken down into other substances. Same with oxygen here. It cannot be broken down into any other type of matter with different properties. Okay, a great example of an element is gold. Gold's an example of an element. And we line up all these elements on our periodic table of elements. So here's our, they call it a periodic chart of elements. I guess it's the same thing. But here we can find all of our periodic table of elements. Hydrogen, helium, lithium, right? And so on and so on. So this shows all the different elements that we've discovered that we can't break down any further by their chemical means. Now, the idea of an atom was an interesting one philosophically. So if we took a bar of gold, and we divided that bar of gold in half, and we looked at this, and even if we divide it in half, both sides are still going to be gold. And so if we divided this half again, even the smaller chunk is still gold. And if we divided that in half again, it's still gold, all these small chunks. Well, philosophers way back when said, well, is there ever a time in which we can divide something and have it not be it anymore? And that's where they came up with this idea of the atom. It's the idea that this is the smallest unit of matter that still contains all of its properties. So once we divide, say we have gold, say we have a gold atom, once we split that gold atom, it is no longer gold. So if we have a gold atom and we split it, and I'm not actually going to draw all the protons and neutrons because it would take forever, but if we were to split that gold atom, it would stop being gold. So it is the smallest unit of matter that retains all the properties. And it contains a number of particles, and this is just to make it simple. It actually contains a lot more, but it contains protons, which are positively charged particles, neutrons, or particles without any charge that just have a mass, so they have a mass to them, and protons also contribute to the mass. And then we have electrons, which are negatively charged. They have a mass, but it's so small that it doesn't really contribute to the mass of the atom. It's negligible. So if we look over here, here is a terrible representation of an actual atom, but it's great for us to just sort of conceptualize. They're actually not found in orbits around these electrons over here. So here's our negatively charged electrons, and over here these are our positively charged protons, and then we have our blue neutrons here. But we can notice that there's a nucleus region, and in that nucleus region we have our protons and our neutrons, and then our electrons are just sort of found floating around outside. They're actually found in what we call probability clouds. So there's these clouds of 90% chance of finding an electron within that cloud, but that's sort of hard to visualize, so we can just imagine them being somewhere outside of the nucleus. Now, moving on from that, so we have elements and we have atoms, and then from there we can form chemical compounds. So chemical compounds are substances formed when two or more elements react with one another. And a great example is this. So if we take a bunch of hydrogen gas, right, and I put a match to it, so here's a match here, and I'll draw some fire. So if I put a match to some hydrogen gas, we're going to get a big explosion. And when that big explosion is done, the hydrogen gas is going to react with the oxygen gas. My oxygen disappeared here. We'll put it down here. It's going to react with the oxygen gas in the air, and it's going to end up forming water. So after this giant explosion, all we're left with is water. So we formed water. So when these two elements react, we form a compound, and that compound in this case is called water. These are held together by bonds. So in this case, oxygen is bonded to a hydrogen, is also bonded to another hydrogen. Okay, and the shape of this is what we call a bent molecule. And so you can notice here that hydrogen bonds with one other thing, so it bonds once. And this hydrogen bonds once, but this oxygen wants to bond twice. And that's because of its chemistry. We'll kind of talk about that. So there's 1 and 2. So it bonds twice. And these bonds are simply just links between two atoms. And they happen for a bunch of different chemical reasons. In this one, they're sharing electrons to make themselves happy, for lack of a better term. So where I want to go now, I just want to look at just a review of states of matter. So we have matter, and it also shows up in a bunch of states. So the first state is a solid, and all the atoms in a solid form together in a crystal structure. And if we look at a really common solid, which is sodium chloride, the atoms sort of form together in this lattice. Let's see if I can sort of draw it here. So they kind of form this really predictable pattern between the sodium and the chlorine, and then they all bond together here. So they form these bonds. They form this, ignore that one there, that's not correct. But they form this crystalline structure of all these different bonds, and they link together and they form this solid. Now within a solid, these atoms do not have enough energy to break these bonds. They don't have enough energy for this atom to go flying off and go by itself. They're kind of stuck together, and in that case they form a solid. If we give this more energy, so if we add more energy to the system, we get a liquid. And in this case, molecules have enough energy to move, but they can't break free of each other. So in a liquid, this is not a very good diagram of a liquid, but in a liquid here, draw little waves, that liquid can take the shape of whatever container it's in, because the molecules aren't stuck together tight enough to keep them from moving. They're able to form to the container. Okay, so they have a definite volume but an indefinite shape. They form whatever container they want to. And then if I gave that liquid more energy, if I give these molecules more energy and allow them to move around more, they'll form a gas. And in that gas, the molecules have enough energy to move and break free, so they're not bonded together. And in this case, the gas molecules, if we see over here, they're free-flowing, and they will take the shape of a container, and they will fill up the volume. So they don't have a definite volume. They'll fill up whatever container we give them. and they don't have a definite shape. They'll fill up whatever shape container we give them. Like if we give them kind of an odd-shaped balloon here with a little tie at the end that we can give to small children at a fair, they'll take whatever shape it is. And the more molecules in there, the bigger we can make this balloon and fill it up bigger, and we can make the volume bigger based upon gas laws and chemistry. So those are just some very beginning introductions of matter, and we'll talk about different macromolecules next. But that's a pretty good introduction into some ideas in matter. So next time we're going to start talking about organic compounds. All right, class, if you have any questions, feel free to ask me anytime. I would love to answer your questions. Have a good day, team.